Hello, today we have this vacuum cleaner on the bench. It's not working at all, so we are going to dive in and find out what's wrong with it.
As you can see, when I press the power button, absolutely nothing happens. It's completely dead.
So let's try to plug in the charger and see if it takes any charge. As we can see, the LED is lighting up, which is a good sign, but when we hit the power switch again, still nothing happens. Let's open it up and see what's going on inside. And the cover is off. Inside we have motor, a battery pack and the PCB. The battery looks a bit sketchy, to be honest, and it's likely worn out. We also have the charging board here, which seems to be a classic setup based on the TP4056 chip. It looks like a motor spins quite freely. Let's check the battery voltage. I will place the black multimeter probe on the negative terminal and the red one on the positive. As you can see, the voltage is only 0.25 volts. That's way too low. Let's plug the charger back in and check the voltage again while it's connected. The LED is on, meaning it's charging and the voltage is climbing, so the battery is accepting current. Now let's verify if the motor is actually functional. I will set my bench power supply to 3.7 volts and the current limit to around 1.73 amps. I will connect the negative lead to the battery ground and the positive lead to the other side of the switch. It looks like the motor needs a bit more current to kick in, so I will bump up the amperage on the power supply. There we go, the motor started up, so we know the motor itself is fine. Let's check the battery again. It is at 2.18 volts, so it is slowly picking up. We will leave it for a few minutes. Now we are at 2.45 volts and still rising. After a few more minutes, it's about 2.7 volts. Let's see if the battery can actually run the motor now. I've kept the voltmeter connected to see how the battery handles the load. The motor tries to turn, but the voltage goes immediately below 0.2 volts. That's a clear sign that the battery is shot and needs to be replaced. First, let's get this bad battery out. For the replacement, I'm going to use a high quality cell salvaged from an old battery pack. I've already tested the capacity and it's around 1800 milliampere hours, which is perfect for this device. It is sitting at 3.9 volts, so it is nearly full. Let's see if the cell can handle the motor. And it runs it without any problem. To connect the battery, I have decided to use nickel strips and spot weld them. First, let's cut two pieces of nickel strips for the terminals. For the welding, I will be using this portable spot welder. It's ideal for this kind of task. It has adjustable power and modes. I have set it to max power and manual mode. Let's position the first strip and start welding. I will hit it a few times in the different spots to make sure the connection is solid. Those joints looks great. Now let's solder the wires to the battery. I will use some heat shrink tubing to insulate the joints. Adding a bit of soldering flux here to make the job easier. Solder the first wire, then the second. Now let's fit the battery back in the housing and tuck the wires away so they don't interfere when we close it up. Let's test it one more time. The vacuum is working perfectly. And let's check the charging one last time. The voltage is slowly rising, so the charging circuit is doing its job. The repair is success. Now we can close it all up. Before we finish, I would like to ask you to subscribe to the channel if you haven't already and hit that like button if you enjoyed the video. Testing it one last time after assembly. Everything works, so let's get those screws back in. The vacuum is running great now. That's it for today. Thanks for watching and I'll see you soon in the next video.